All right, here we go. This is lesson 8 on rational expressions. And today we're going to add them and subtract them all with common denominators. So we're going to ease our way into this with common denominators. So let's take a look. Remember, rational expressions are nothing more than crazy fractions. And what do we know about adding and subtracting fractions? Like if we have a half and we add that to 3 halves, what do we have? We have 4 halves. So remember, the premise of all this is that when you add and subtract, you don't add and subtract the denominators. It's only the numerators that add and subtract, but that's assuming your denominators are all common. That means they're all the same. So today everything's going to be the same, so we're only going to worry about the numerators. Should be pretty straightforward. So here's an example. Let's say we have 2 over 10x plus 5 over 10x. Now, right off the bat, you're thinking, hey, I can simplify that. And you can. You're not wrong. But if you simplify it, you're not going to have common denominators anymore. So we're going to leave it right now, and we're just going to add our numerators and get 7. In our denominators, we don't change. So 7 over 10x, right? Easy enough. That process doesn't change. That rule doesn't ever change. You might have order of operations thrown in, but stick with that rule, only the numerators. Okay, let's look at another one. What if we have 1 over 8x plus 7 over 8x. Okay, same deal. Add your numerators. 1 plus 7 is 8. Denominator stays the same, 8x. Now this has an extra step because we can cancel or simplify that 8 right there. So when you do that, they both divide by 8. So you're going to, 8 divided by 8 is 1. So what you actually have is 1 over x. Don't lose that 1. It's tricky, but that x needs to stay in the bottom. Okay, does that make sense? All right, let's try another one. What if we throw a little wrench in this? What if we have 2x plus 1 over 4? And we're going to add to that 3x plus 2 over 4. Now it looks more complex, but stick with our rules. We have a common denominator. That means that our answer has to have that same denominator, 4. We're going to add and subtract these. This is the same as having 2x plus 1 plus 3x plus 2. That's what we've been doing in the other ones, right? So now we need to collect our like terms. So we've got x's and we've got whole numbers. So if we do that, we're going to have 5x plus 3, right? 2x plus 3x is 5x, and 1 plus 2 is 3. And our denominator hasn't changed, still 4. Take a look. Make sure there's nothing that you can factor out and cancel, and there's not. So we're done. Let's try another one. 3x over 3 plus 6x plus 3 divided by 3. Okay, again, common denominators, so we're just going to leave those. In the top, we're just going to add all of this together across the top. So 3x plus 6x plus 3. Collect your like terms. 9x plus 3 over 3. Now that final piece again, I've got 9s, 3s, and 3s. Is there something I can factor out and then cancel? In the numerator, 9 and 3 have what in common? They both divide by 3. So I'm going to factor out a 3. And 9 divided by 3 is 3, well, 3x. And 3 divided by 3. So if I factor the 3 out of that 3, leaves me a 1. Don't lose that 1. And in the numerator or denominator, we still have 3. Now, these cancel, and all that's left is 3x plus 1. Final answer. So this one had lots of steps. So let me go through that again. We kept our common denominator the whole way through. In the top, we added everything straight through, collected like terms, factored out a common factor, canceled. The end. Okay, that's good. That was good. What about this? 2x over 3 minus 4x over 3. So what's different here? We've got subtraction. Same deal. The denominator's common, 3. We're going to leave that. Now we have 2x minus 4x. Now, red flag. Subtraction doesn't behave. Now in this one, it does. In this one, we just straight up have 2x minus 4x. Well, what is 2x minus 4x? It is negative 2x over 3. Does anything cancel? Nope. We're done. But watch this. 2x plus 5 over 5 minus x plus 2 over 5. So, common denominators, always a good thing. I'm going to start with my common denominator. Now, I think it helps you see subtraction if you put brackets around it, specifically around the second one. So what's happening here, just like we did before, we're going to put it all in the top. So 2x plus 5 minus x plus 2. Here's where this gets tricky. This subtraction means we have to subtract the x and the 2. This subtraction applies to the whole bracket. So it's almost like having, well, it is like having a negative 1 right here. It's like you have to multiply that negative 1 all the way through. So be careful. This is actually going to be 2x plus 5. And then you're going to distribute that x. So minus x, and then distribute it to the 2, minus 2 over 5. Once we've done that, we're back to where we were, and we can collect like terms. 2x minus x is x. And 5 minus 2 is positive 3, so x plus 3 over 5. There's nothing we can cancel, and we're done. So when you have subtraction of a binomial, you have to really, really, really be careful. That's a red flag. Watch out for it. Let's try another one that looks like that. 3x plus 4 over 4 minus x plus 2 over 4. Again, I see my binomial, I see its subtraction. I'm going to go ahead and throw some brackets around that one so I don't forget. I've got a common denominator of 4. Just going to leave that. I'm going to use my first one, 3x plus 4. Now I need to subtract both pieces. So I'm going to have minus x plus 2. I'm going to rewrite it and distribute that negative. So minus x minus 2 over 4. So collect like terms. Where's my like terms? Let's see. I've got a 3x and a negative x, and I've got a 4 minus 2. So that's going to give me 3x minus x is 2x, and 4 minus 2 is 2 over 4. Now look carefully in that final step, 2, 2, and 4, lots of even numbers. I can factor out a 2 in my numerator. That's going to leave me 2 times x plus 1, don't lose your 1, over 4. This 2 will cancel there. So our final answer is x plus 1 over 2. How did we do on that? You want me to walk you through that one more time? I saw that I had a binomial that was being subtracted, so I put brackets around it. Right here is how I wrote that out. We distributed the negative through the binomial. So 3x plus 4 minus x minus 2, because you have to subtract the whole bracket. Collect your like terms. 3x minus x is 2x. 4 minus 2 is 2. Factor out the 2 on the top. Cancel that out and simplify with the denominator, and we are left with x plus 1 over 2. Okay, let's try one more. Just to be clear, we'll give you one last example. So 12x minus 5 over 6 minus 2x minus 7 over 6. So again, common denominator. I'm going to rewrite this with my brackets. So 12x minus 5 minus 2x minus 7 all over 6. Just to be clear, this negative, the subtraction sign doesn't impact anything. That just means we're subtracting 5. It's only the two rational expressions being subtracted that has an impact. Okay, we're going to distribute. We're going to distribute this negative onto the 2x and the negative onto the negative 7. So it's going to change that. That's going to give us 12x minus 5 minus 2x. A negative 7 is plus 7 all over 6. Collect your like terms. 12x minus 2x is 10x. Negative 5 plus 7 is 2. Oh, sorry, I should write that in blue. Is 2 over 6. Look carefully. Is there something that we can factor out here? We can factor out a 2. Factor out your 2. You're left with 5x plus 1 over 6. This 2 will cancel with a 6, leaving you a 3. So then your final answer is going to be 5x plus 1 over 3. So that's about as hard as they get for this common denominator. So the key here was that the subtraction in the first binomial didn't bother us, but subtracting the second binomial that had a negative does change that. A negative is a positive. So be very careful. Make sure you factor out any common factors, like we had a 2, and then make sure you simplify. And there's your final answer. Good job.